Today we'll talk about section 11.1 on simple interest. There are several terms that we will regularly use. Interest is the amount of money paid by a financial institution on a certain amount of money deposited. It's also used to describe the amount of money that's paid to a financial institution in order to borrow a certain amount of money. Principal, or present value, is the amount deposited or borrowed. And future value is the amount of money that will be in the account after T years. In other words, the future value of the money. There are two types of interest received from accounts of deposit with financial institutions or incurred when taking out consumer loans. If the amount of interest is based only on the amount of money borrowed or deposited for a fixed period of time and is not affected by periodic payments made toward the amount owed or borrowed, then the interest is called simple interest. Take a ridiculous example where you had 50% interest payments, simple interest payments. If you start out with $100, after year one, 50% of 100 is 50, you'd get a $50 payment. After year two, you'd get a $50 payment, and after year three, you get a $50 payment. The simple interest idea is that the principal stays the same and you get a certain amount off of that each year. That's simple interest. A good way to think about this is with a simple interest account, the interest that you receive on the principal does not earn any interest itself. The principal, in this case $100, earns interest, but the interest payments themselves, the $50, never earn any interest. The second type, called compound interest, is something we'll talk about in the next section. Let's focus on simple interest. The formula for calculating the amount of simple interest is given by capital I is equal to capital P RT. Capital I is the amount of interest earned or paid. Capital P is the principal or present value. Little r is the interest rate written as a decimal. And sometimes little r is called APR, which stands for annual percentage rate. And little t is the time in years. It has to be in years. For example, $500 is deposited in an account paying 6% simple interest. How much interest will the deposit earn in 4 years? You simply plug into the formula. The principal is $500. That's how much you deposited. The interest rate is 6%, written as a decimal. You move the decimal 2 places to the left. That gives you 0.06. And you're doing it for 4 years, so t is equal to 4. And if you multiply those three numbers together, 500 times 0.06 times 4 equals, you get 120. So you'd make $120 in interest if you put $500 in for 6% interest for a period of 4 years. And if the interest were simple interest. Sometimes you don't want to know just the amount of interest you earn. Sometimes you'll actually want to know how much money's in the account after 4 years, or however many years. And to do that, we just take the interest, which was $120, the amount of interest, and add it back to the principal, which is $500. So the principal plus interest gives you the amount of interest in the account, which is $620. That $620, the total amount in the account after a certain period of time, is called the future value. And as always, when you're doing these calculations, your final step should always be trying to see if your answer at least seems fairly reasonable. So if you take $500, put it away for 4 years at a pretty good interest rate, does it seem somewhat reasonable that you might end up with $620? And I would say yes. If the answer had come out to be $6,200, I would say no, that's probably a mistake. That sounds wild. So always think about that when you do a calculation to see if your answer even seems reasonable. If it doesn't, you can probably find your error and fix it. Another example. If you withdraw part of your money from a certificate of deposit before the date of maturity, you must pay an interest penalty. Suppose you invested $7,000 in a 1-year certificate of deposit paying 8.5% interest. After 6 months, you decide to withdraw $7,000. Your interest penalty is 3 months simple interest on the $7,000. What interest penalty do you pay? And round your answer to 2 decimal places. Now that problem is very wordy, but if you just read one of those very last sentences, that's really all you really need to know to do the calculation. It says your interest penalty is 3 months simple interest on the $7,000. So all you need to do is take your interest formula, capital I is equal to capital P RT, and figure out what the amount of interest would be on that. So $7,000 principal at 8.5% would be 0.085 for R, and your time always has to be in years, so 3 months is 3/12 of a year. Notice that 3/12, if you take your calculator out, is just 0.25, and if you multiply those three numbers together, you'll end up with $148.75. That would be the penalty you would have to pay for withdrawing that $7,000 early by 3 months. Now, just to summarize, I put the formula back up here again. The formula for calculating the amount of simple interest is capital I equals capital PRT, where I, P, R, and T are as defined earlier. That's the amount of interest. If I want to know how much is actually in the account, I'm going to call that capital A. The future value is capital A. It's simply the principal plus the interest. We've already talked about that. But notice that I, capital I, is really PRT. So if I took that capital I out and substituted PRT, I have a capital P in both terms. I could actually factor a P out and get P times the sum of 1 plus RT. That's really the easiest way to write this. If I get out the clutter in the middle, I get a formula for future value for simple interest, and it's capital A is equal to capital P times the sum of 1 plus RT. That formula will take you directly to the amount in the account without calculating the amount of interest first. You can always calculate the amount of interest first and then add it back to the principal, but if you're only interested in how much is in the account, this is a little faster. That capital A again is called the future value for a simple interest investment. So going back to that previous example, before I wanted to know how much interest would be earned after 4 years. Suppose this time I just want to find the future value of the investment in 4 years. That means I want the capital A. I can use this formula. I know that I can get it by taking P plus capital I and getting 620 because I did it a minute ago. But what if I want to go directly for the amount without actually calculating capital I first? All I would have to do is plug 500 in for capital P, 6%, which is 0.06 in for R, and T is equal to 4, and do the calculation. 4 times 0.06 is 0.24, 0.24 plus 1 is 1.24, and 1.24 times 500 is 620. It's the same answer I got earlier. You can do it either way. This formula is actually faster if all you want is the amount in the account, but you can certainly calculate it the other way as well. We'll say one other thing. This formula can also be used to calculate the total payback on a simple interest loan from some financial institution if you borrow money with simple interest. In this case, capital A is called the maturity value of the loan, and it represents the entire amount paid back or to be paid back, which includes both the principal and the interest. So capital A can be the future value for a simple interest investment. Capital A can be the maturity value for a simple interest loan. The same formula is playing double duty. How about this? Find the maturity value of an 8th month simple interest loan of $8,000 if the interest rate is 9.75%. Again, I want the maturity value, so I use the formula A is equal to P times the sum of 1 plus RT, and I plug in all the values. The principal is $8,000. The interest rate is 9.75%. If you move the decimal 2 places to the left, you get 0.0975. And you're doing it for 8 months, but the answer has to be in years, so you get 8/12 of a year. 8/12 is about 0.666667. If you multiply that by 0.0975 and add 1 to it, you get 1.065. And if you multiply that by 8,000, you get about $8,520. So the maturity value of an 8th month simple interest loan of $8,000 at an interest rate of 9.75% is $8,520. And this one, your electric bill is $124. You are charged 8% simple interest for late payments. How much do you owe if you pay the bill 5 months past the due date and round your answer to 2 decimal places. Again, same formula. The principal is the amount of the bill, that's $124. The interest rate is 8%, that's 0.08. You're doing it 5 months late, so that's 5/12 of a year. 5/12 is about 0.416667. Multiply by 0.08 and add 1, and you get 1.033333, and you multiply that by 124, and you end up with $128.13. I know I say this a lot, but don't round too much in the preliminary calculations. Carry more decimal places than you think you need, and then round at the end. Rounding too early can cause you to be off in the final answer. In reality, simple interest is not frequently used in average consumer transactions, but when it is, it's often used for just short periods of time. For example, let's calculate the simple interest due on a 3-month loan of $2,000 if the interest rate is 6.5%. It's a 3-month loan and the time has to be in years. So as before, we have to change that to years, months to years. 3 months is 3/12 of a year. 3/12 is 1/4, so T is equal to 1/4. You have to go from months to years for the formula to work. So the capital I equals capital PRT will give you the interest due. We're looking for the interest due this time. $2,000 is the principal, 6.5%, which is 0.065 is the interest rate, and the years is 1/4 of a year. 3 months is 1/4 of a year. 1/4 is 0.25, and if you multiply those 3 numbers together, you get $32.50. So the interest due on a 3-month loan of $2,000 at 6.5% simple interest is $32.50. I can't emphasize enough, the T has to be in years. So when you're given months, you have to divide by 12 to get the number of years. How about this? Let's calculate the simple interest due on a 90-day loan of $2,000 if the interest rate is 6.5%. This is a little different. We've been doing years and months. This is a 90-day loan. So you still have to change it to years, but you got to think a minute. There are 365 days in a year, so 90 days is 90 365ths of a year. And if you do that on the calculator, that comes out to be about 0.246575. Again, take plenty of extra decimal places. You have to convert it back to years. And if you're doing days, divide by 365. Same formula. The principal is $2,000. The interest rate is 0.065, which is 6.5% written as a decimal. And the time is 0.246575. And if you multiply those 3 numbers together, you get $32.05. So if you take out a 90-day simple interest loan at 6.5% where you've borrowed $2,000, you will owe $32.05. Dividing by 365 is called the exact method. I'll show you why with the next example. Not all months have the same number of days. You probably know that. So some institutions just simplify their calculations by pretending that every month has 30 days. But 30 times 12 is only 360. So if they do that, they're working with a 360-day year instead of a 365-day year, just for the purposes of interest calculations. This is called the ordinary method. So if you go back to the previous problem, the exact method uses the exact number of days in a year, which is 365. The ordinary method pretends there's only 360 days in a year and uses 360 instead of 365. So the calculation is exactly the same if we want to do it by the ordinary method instead of the exact method. So if I take that exact same problem, but this time doing it using the ordinary method, the only difference is converting to 90 days, I divide by 360 instead of 365. So ordinary method, divide by 360, exact method, divide by 365. I'm doing the ordinary method here, so I want to divide by 360. So 90 divided by 360 actually comes out to be 0.25. Otherwise, the calculation is exactly the same. P is 2,000, R is 0.065, and now T is 0.25. If you multiply those three numbers together, you get $32.50. So now you owe the bank $32.50 if you're calculating using the ordinary method. It turns out that most financial institutions actually do use the ordinary method when dealing with days. So if you have a problem where you're doing days, unless it says differently, assume that you're going to be using the ordinary method and dividing by 360, unless it tells you to do otherwise. And as a side note, the ordinary method is actually more favorable to the lender. How about this one? Calculate the simple interest rate if P is equal to 2,400, I is equal to 44, and T is equal to 4 months. We're looking for the interest rate. So we use the formula capital I is equal to capital PRT, but this time we're solving for little r. So we know that the amount of interest is $44, that's capital I. The principal or present value is 2,400, and it's 4 months, that's 4/12 of a year for T. And of course 4/12 is 1/3, and 1/3 times 2,400 is 800. So you get 44 is equal to 800 R, and if you divide both sides by 800, you end up with R is equal to 0.055, and if you change that to a percent, you get 5.5%. There is another thing that you should watch out for. Read this problem carefully. Calculate the simple interest earned if P is equal to $2,280, R is equal to 5% monthly, T is equal to 11 months, and round answer to the nearest cent. Do you see anything about this problem? There is an important difference in the way this problem is stated compared to earlier problems. It's the fact that the interest rate is given as a monthly rate. Typically, interest rates in previous problems we've solved were given as annual rates, not monthly rates. And that's why time in the simple interest formula had to be given in years, and why we had to change months to years by dividing by 12 before plugging into the formula. Because if the rate were given as an annual rate, then the time had to be in years. But if the rate is given as a monthly rate and T is given in months, then we don't need to divide by 12 at all. And actually the problem is very simple to solve, but you do have to notice that fact. So to solve this problem, just apply I equal PRT, plug in $2,280 for P, 0.05 for R, and 11 months. Remember, we don't have to divide by 12 because the annual rate is not given here. It's the monthly rate, and the time is in months. As long as the units match, we're good. Multiply those three numbers together, and we get $1,254. Keep in mind that that answer seems relatively large. You're not used to seeing an 11th month loan on $2,280 paying $1,254, but that's because the interest rate is given as monthly, and 5% monthly is a huge interest rate. If you multiplied 5 times 12, you'd get a 60% annual interest rate. So in this case, warning you to look and see if your answer makes sense is a little trickier, because you've got to think of that monthly rate as an annual rate when you're trying to think, does that make sense? So here, because 5% monthly is really equivalent to 12 times as much, that answer actually does make sense. And keep in mind, these problems don't pop up all the time, so you just have to keep a close eye out for an interest rate that's given as monthly instead of annually, and it doesn't happen very often. So here are the formulas you will need to do your homework.